Let's look at how to make a Nyquist plot for this example. First of all, we um, determine the magnitude and the phase angle of these functions. In particular, here I want to give you kind of a notice. This one should be fine. This one doesn't matter. The omega value, the always is this one. And for the same thing for this one is angle doesn't matter. For the value of the omega is always tangent, arctangent omega. However, for this one, let me explain. And say when omega is positive, so basically this is a -1 when omega is a positive value, so that value is here. Okay, so that value is here, so we can see the angle is 90 degrees plus one little one, and that little one basically is arctangent of 1 over omega. If you look at this triangle, you can figure it out. Okay, on the other side, when omega is negative, for example here the point is here, so here the angle basically is minus 90 degrees and minus a little bit more. And this one again is arctangent. You can figure out from this angle, from this triangle, and actually that is this one. Okay, so here we have the things, and then we sample a few points to plot. So let me pick this is S1, and S2 is very close to the origin, and S3 again a little bit below the origin, and S4 is here, and this is called the Nyquist path. Okay, Nyquist path, Nyquist and path. Okay, and with the radius equal to infinity. Okay, and then we keep going, so there's a 4, and then we pick the 5 here and on the circle, and this is x6, and here is s7. Okay, so here we make the things here, and this is the magnitude, and this is the angle. Okay, so for the first sampling point s1, and that is at j infinities for this point here. So under this situation, we plug in here the magnitude equal to 0, and the phase angle we plug in omega equal to infinity positive, and plug in this equation here. You should be able to find that is 90 degrees minus. Okay, and then so we can begin to label the points on the GH plot. So which means this complex plane for plotting this. So let me label this is the capital S1. So capital S1 has a magnitude equal to 0, and the phase angle is 90. So basically it's about here. Okay, let me do this one. This point is very, very close to the imaginary axis and below a little bit. So because that angle is minus 90. Okay, we move on to S2. So S2 will be equal to J and small positive numbers. So plug in omega equal to 0, that is equal to 2. And plug in omega is positive and 0, this is minus 180. Okay, so that is S2. So the magnitude is 2, and then the phase angle minus 180, so that is S2 here. Okay, and so transition from S1 to S2, basically that is similar in trend like this. Okay, so this point is S1, so let me say S1. Okay, so we move on to S3. So S3 equal to J minus. Okay, so this is 2, and then this is minus 180. Okay, so that is corresponding S3. So S3 is nearby, just above this axis here. So that is S3. So we down to S4. Move on to S4. So S4 is J infinity minus. Okay, so J infinity minus, and plug in omega equal to infinity, that is 0. And when omega equal to less than 0, we plug in this equation. That will give us the value equal to 90 degrees. And let me label this is S4. So for S4, that should be here. Okay, very close to the origins, and the phase angle is 90 degrees. So let me label that is S4 here. So now to S5. So S5 basically is on semicircles. So with the radius R, and its phase angle is 90 degrees. Okay. So basically here the R equal to infinity. So plug in here the magnitude equal to 0. And then we plug in a phase angle that is minus 90. So you can plug in here, and after plugging using the second equation here, 90 degrees. So let me take out 5. So the magnitude 5, and then so basically that is S5. Basically S5 is very close to S4. Okay, so they basically overlap, and S6 equal to R, and S6 is here, so that is 0 degrees. Okay, so again we plug in R equal to the magnitude equal to here, so that is 0. And when the phase angle equal to 0, we plug in here, and then you can see that basically is 180 degrees. Okay, and then we'll label that is S6. So basically S6 is very close to origins and at the 180 degrees here. So let me zoom in, so that is S6 here. Okay, then we go to S7. S7 equal to R, and S7 is on the with a phase angle 90 degrees here. So that is 0. And we plug in, so basically is 90 degrees. So let me label this is 7. Sorry, this is 6. Okay, so 7 basically is very close to S1. Okay, so here is S7. So basically here you could say this angle, this plot is this, and this is a very small semicircles, very close to the origins. But when we zoom that should be like this. Okay, so basically this is we complete the Nyquist plot for this function just like this. Thank you.